Hey guys, what's up? It's your boy Trix. Today we're going to be doing some Akka data pipelines with Akka streaming data pipelines simplified. As always, I will be rocking some IEMs. Today is the Dusks, and if you want to know what I'm listening to, check out my GitHub page with my updated music streaming data. Yeah. Anyway, let's get into this. Developing, orchestrating, and operating distributed streaming applications in Kubernetes is a difficult proposition. Tools from Lightblend. Ooh, it's been a while since I coughed, and that's like the first one today. Whoa. Tools from Lightblend, such as Akka data pipelines, can accelerate development and decrease risks. Akka data pipeline simplifies the complexities of streaming data pipelines, making it faster and easier to build, test, deploy, and run them. This guide covers the following topics: what is Akka data pipelines and why you should care, how to set up a local Kubernetes test environment using micro Kubernetes, that would be interesting, how to install Akka data pipelines, how to test and run a sample working windmill sensor data application. Sample demonstrates an IoT proof of concept built using either Java or Scala programming languages, and open source Akka Streams Toolkit. What is Akka data? Oh, by the way, if you see my hand like moving like this, it's because I'm using a trackball mouse, so I can like put it on my leg and like use the mouse, so I don't actually have to put it on the desk. Sometimes I just do that if I want to like chill and read. The Cloudflow open source project enables you to quickly develop, orchestrate, and operate distributed streaming applications such as Kubernetes. Akka data pipelines as Lightblend console and telemetry to the capabilities of open source Cloudflow. I wonder what telemetry it's using, because you could use like open telemetry, and like other telemetry frameworks which help with logging. Open telemetry is pretty new, so I don't think I'll be using that one right now. Interesting. Lightblend console. I keep saying Lightblend when I mean Lightbend. I'll be doing that a lot this stream, sorry. Sorry in advance. Lightblend console enables you to observe and monitor Lightblend platform applications running on Kubernetes. Telemetry provides the needed visibility into the health and performance of your production and streaming services. Most of the time, like telemetry. Basically, I went to a talk a while ago where Ben Evans, he's like one of the Java champions, was talking about open telemetry, and lots of people only do like the logging side of it, which is fair, because then you can like use like Grafana to visualize what the data you're collecting, right? But some people don't like use alerts or tracing or some other stuff that is helpful. And he was just doing a talk on how you can like combine these things together, and even though you only use one, think about using other ones and like their applications. Don't just write them off because you currently don't have a use for them. You could have a use for them in the future. Like tracing is really useful if you have like multiple sources for your logs and you're trying to follow the source through, like say for example you have a HTTP request, right? And then you have like multiple containers that your request is being passed through. You could use tracing to show the path that HTTP request goes through your containers if you're logging in all of your containers for different things that HTTP request could be doing. Tracing is really useful because instead of having to recheck a new like ID or log to like link everything through your containers or like through your logs, your trace will just show the path of that like request through your containers or something, through all of your logs, just for that one HTTP request. So you can follow it all the way through without having to request like Loki or Elasticsearch or something with Grafana. It's really cool. It's just some people don't implement it because they currently don't have a use for it. But knowing how you could use it and like how useful it is, I think like lots of people should look into it. You don't need to use OpenTelemetry, but just thinking about how you could potentially use like tracing alerts, stuff like that. Alerts is like very common if you have like a production system, and same with like logging and visualization. But lots of people like neglect tracing. I feel like it has its place, and if you are like aggregating a ton of logs, tracing could be very helpful for you if you need to track down a specific instance in your logs. Akka data pipelines include the benefits associated with the light blend solutions such as training and support. Everything with money. Building streaming data pipelines with Cloudflow. Cloudflow assists you in quickly developing distributed streaming applications on gates. Sorry. Let me just move this bit forward. There you are. You should be able to hear me better now. By eliminating the need for writing boilerplate code and associated YAML files for deployment and configuration. This capability massively reduces the time required to create, package, and deploy streaming applications from weeks to hours. Cloudflow streaming applications contain small composable components called streamlets. Streamlets connect together through strongly typed schema-based contracts in a schema-first approach. To create a streaming data flow, we simply hang on. There. To create a streaming data flow, you simply supply schemas in either Avro or protobuf format that represents a domain model. In this guide, we'll use protobuf for the example. To explain, like Avro and protobuf is kind of also like SPE, where you use a schema to define how you want a data type to be handled over like the way that I've seen it being used has been like HTTP requests or like specific objects that you want, where it could be passed over a network and then you can like map it to that object afterwards. So if it's going over the network, you could use something like protobuf, Avro, SPE, and it will just shape your data how you want it to with different encoders. I know Avro and protobuf are very popular. SPE is pretty new, I want to say, but SPE is really nice just because your schema looks... The schema is very easy to understand. I haven't really looked at Avro and protobuf schema, so getting the opportunity to look at them in here probably be pretty cool. And connect schemas in a single deployable blueprint. Blueprint declares which streamlets join together to form a pipeline. For example, the IoT POC blueprint is as follows. Okay. Purely because it has topics and it's using protobuf, I think they're going to be sending the data over Kafka. I could be wrong on that. Kafka is very popular with like IoT devices and IoT, what's it called? Communication between IoT devices. I say that, but Matter and like, what's it called? Zigbee are also popular, but those aren't between end devices. They're more, but that's built between like an end device and a hub. So Kafka. I knew it. As soon as I saw the topics, I was like, Kafka. Just to say, there's nothing wrong with Kafka. Like, Kafka's pretty good on its own. It's just like this is using it in like a sensible way. Some people are just using Kafka because they just know Kafka and don't like think about why they should be using it. Like if you have topics like this, it makes sense where you want to segment the data that you're sending over because the topics you have are completely different. But if you're just like slapping a timestamp into your topic, what's the point? your topic should be like aggregating your data so that when you retrieve your data from Kafka, you're able to like map it correctly. If you're just slapping it using Kafka, slapping your topic as like a timestamp or something, or your topic's just always the same. Use a more lightweight message processing. Oh, what's it called? Like what Kafka is. It's a message processing framework, right? Hang on. Publisher subscriber model. There we go. Use a different publisher subscriber model. Like there's MQTT, Kafka, RabbitMQ. There's a ton of them out there. If your data that you're sending over needs to have unique topics or like filters or something so you can map your data correctly, sure, go with Kafka or MQTT because they are like topic based, right? But if you're not doing that and you're just like using a random topic there, or you're not even providing a topic at all, it's just a random string or something, no real point. Especially if you know that the topics you're receiving or receiving are always going to be the same, being mapped to the same object. There's no real point. Like in here, it makes sense because you could have valid and invalid metrics. Yes, it is a bit convoluted that you're using Kafka in multiple places. But if you're just carrying data and like, let's say here, it's being filtered and then being remapped to metrics, filtered and remapped with metric validation, fair enough. But if it's purely just to get it from the ingress point to sensor data metrics, no real point. Because then you could just like do gRPC ingress all the way to metric validation if you're just using this as a converter to get it into metrics. I would expect like maybe this middle section to have different objects that will try to be mapping to, where Kafka would make sense because it's sending over different topics. Valid, invalid, sensor data. Notice the insertion of Apache Kafka calls between each connected streamlet. In this example, Kafka possesses elements of the data stream between streamlets. Kafka topics add redundancy to their overflow and allow streamlets to be scaled up or down independently. In the case of failure, streamlets are restarted and pickups right where they left off without losing any data. Streamlets can be created using the best streaming engine for the task at hand. Sorry, I'm listening to music right now and I can't hear myself talk. And I don't know if I'm like shouting or whatever, so I just took one out while I'm still listening. So, including Akka streams, Flink or Spark. Akka and Flink streamlets can be developed in Scala or Java. Spark streamlets can only be developed in Scala. Similar to puzzle pieces, streamlets also have a shape. A streamlet shape is defined by its inlets and outlets, and their associated schema types. Each streamlet may have 0 or more inlets and outlets. As shown in the example below, the validation streamlet has one inlet of the type metrics and 2 outlets, with one being a type of invalid metrics and the other being valid metrics. This shape is also known as fan-out. As mentioned previously, streamlets aren't required to have either an inlet or an outlet. In these cases, streamlets are usually integrating. I'm just gonna like this song. Yeah, it's like nice. Something outside of the application, for example, common use cases to have an Akka streamlet with no inlet. However, data from outside the world is pulled into the flow through one of the Alpaca streaming connectors. Another common use case for streamlet without an outlet to persist data in a database or data lake at the end of a flow. Yeah, that would make sense because if you have like, if you're using like MQTT for like time-based events, you could. I'm talking about from previous experience when I was at like university, like where we had like an MQTT. We were using MQTT to send data to a time. What's it called? real-time database, sorry, on the tip of my tongue and everything, and I couldn't say it, to a real-time database to collect metrics about a SBC. It was pretty cool. Akka data pipeline framework greatly simplifies the complexities of building, operating, monitoring streaming data pipelines. Teams can focus on building business logic and the application of machine learning to actionable data instead of worrying about the underlying framework. And this will take a look at running K8s locally on your machine and then running on our sample app data pipelines to IoT POC application, setting up your environment. I really don't want to run micro 8s on here. For context, the only reason there are two main reasons I don't want to run this right now. One, I don't particularly like the software that Canonical pushes out. Ubuntu is fine. Ubuntu server is great, right? Ubuntu desktop is mid. I remember using something similar to micro K8s a while ago. It was called like MicroStack. I think that's the one from Ubuntu. Hang on. Yeah, I was using this a while ago for OpenStack, and it's just I know lots of people probably get it working, probably can get it working, but I couldn't. I know it's painful. I got it like kind of half working, but like the plugins that you can use with OpenStack are just weird. It was only like specifically for a version that wouldn't run on MicroStack, and now that there's micro K8s, I don't know if I want to run this. I'll still like go through the tutorial and everything. I just won't run it locally. Accordion is pretty cool. Helm 3 is pretty good. I don't know how I feel about Trophic just because it's built in Go, but I can't really chat because I've done Go on this channel, right? But I didn't particularly like Go while learning it, so... Oh, it's plus HP too, nice. Sick. The 2E output looks pretty good. It just looks like the normal Docker output. Well, I'm guessing that's what it should look like, considering Kubernetes is just Docker, right? It's just scalable Docker containers. To be fair to Trafic, configuration for Trafic is a lot nicer than it is for like HA proxy and Nginx. Like when I was trying to set up Nginx like a while ago, Nginx was painful. HA proxy isn't that bad. Like the documentation for HA proxy is pretty good. I remember with Nginx, I had to what was it? I had to find like a random blog post that explained how to like configure it properly. And I was like, I was trying to run Nginx in a Docker container to execute some Java. And I was like, okay, let's try this. Painful. It was literally to like port forward it was to port forward a local web server, and which was painful. The UI for Nginx is really nice though, like the web UI, but doing everything from config was painful. I don't even think HA proxy has a UI, which is probably why like HA proxy's config is like very nice. It's just confusing at times if you don't reference documentation. But like everything needs documentation anyway, so like if you read documentation, you won't find it that hard.
It is kind of like Gradle. Protobuf uses message pack, right? Oh, message pack is different. There. For context, I have button shortcuts for forward and back in the browser. That's what that was. The syntax for Protobuf doesn't actually look that bad. Compared to like XML, it's a lot shorter. And compared to, I mean, XML is used for SBE and for, I think, Avro as well. So it is pretty short. I wonder how... I don't know if I like that. Basically, the way that SBE handles it is you have a version at the top that you can specify what version the current SBE message that you're trying to encode and decode is. And if it sees that it's like an older or newer version, it just handles it and knows that, oh, some fields aren't there or some fields are. I don't know if I like this because you could just change the protobuf message and then, oh, if you renumbered things, which is like valid if you're moving data around or like moving how you structure your protobuf class, right? Your protobuf mapped class, and like maybe you might change a data type or a field to be a different data type, which is like very common if you've like done some optimization on it. It's very weird that it doesn't just like allow you to specify that, oh, on this version do this, on this version do that, which is pretty much what SBE does. I guess there's a downside to everything, right? SBE just has like a massive XML doc that you have to go through, whereas Protobuf just doesn't handle versioning nicely. Sick. Also very weird that additional fields and changed fields are considered optional. I'm saying that because, like, say for example, if you're doing like a rolling release, right? Well, technically it's called rolling. I call it rolling. It's not actually called rolling. But like, let's say you are upgrading your systems in production, you would do well. The way that I would see it is you would upgrade some, and then like continue to upgrade them as you like upgrade each individual one, so you know that, oh, nothing's gone wrong. If you have new messages and they're considered optional, that's okay. But you could like have critical logic that relies on that data being fed back, and if it's not there, I wonder what happens. I feel like whatever you're running will just go bang, right? You'll probably always have that issue if you're adding data or like removing data and you're just expecting it to exist. and if you haven't like accommodated that this might not exist anymore, would probably just go bang. I actually wonder now, how do like big companies like Amazon or Google handle updating their systems? Because they have like tons of systems, right, that they need to update. So how do they? Because their SLA is that you'll have like no downtime, right? Interesting. Not even hundreds, like thousands, maybe even a million systems. Like I don't know how. That's weird. I'm guessing that's just provided by Protobuf. Oh god. I don't even want to know how this does it. You know what? I can guess how it does it, and all I see when looking at this whole like block is that's a ton of applications. Like Jesus Christ. Well, I guess if you're gonna loop over it anyway, you're probably gonna allocate a ton anyway. But that's still a lot. Whew. Hmm. Hmm. I thought I saw regex for a minute. That looks very regexy. Yes. I was like, oh, I thought I saw regex for a minute. Literally says regex. Sick. Oh. Hmm. Nice, they're using completable futures. That's what you like to see. Oh yeah, I saw this the other day. That was actually really cool. Uh, with with Java, I saw like in a Stack Overflow answer that allowing the JVM to handle the size dynamically apparently works faster, is like a lot faster than you specifying a given size to an array list. So like that all futures result for that array list, it's a lot better for you to make that new array based on that size of 0 and just letting Java allocate the objects to that new completable feature array dynamically than you specifying the size, because Java will just add the elements on into that list straight away instead of allocating memory space for that list based on the size that you've specified and then copying over the data to that array list. It's really cool. Basically, Java's faster at allocating the data for a list dynamically than it is for you saying, oh, I want to have this number of elements, because it will then have to go and find space for it, allocate them, and then do what you want. Because I'm pretty sure the space is all like in contiguous memory, right? Whereas if you just let Java allocate the space dynamically, it'll just put it anywhere. Yeah, Gatling is sick. Okay, I'm going to give my review of this tutorial. Who do I think this tutorial is for? Anybody interested in Kubernetes, streaming, Kafka, containers, data serialization and deserialization into objects. Check this out because it's pretty good, especially if you want to do like metrics and logging and stuff. This tutorial seems pretty good. What did I like about it? I like that it touches a lot of things. Protobuf is like serialization, deserialization libraries like Protobuf, SB, Avro. I don't want to include Jackson, but Jackson kind of. They're not very common unless like you've touched requests before, and seeing it in a tutorial where I genuinely wasn't expecting this, really cool. Touches Kafka too, touches Kubernetes. For all the technologies that touches, I think it's pretty good. I'm not as familiar with Kubernetes as I am with like other technologies. Same with Kafka. I'm more familiar with like MQTT, but from the data flow diagrams that I saw, it looks like it covers quite a bit. The Kubernetes side doesn't seem like it's as strong, but it does cover like how it works in the output that you're expecting and stuff like that. I'm gonna leave what I didn't like for last. I think if you want to get your hands on and like try doing stuff like this, I say give it a go. You don't need to do it with an IoT application. You can just do it with like sending data over a network and just seeing and just mapping the data and like collecting metrics about it. That's okay as well. Like that's basically how like AppWrite or like Firebase works, where it like collects metrics about people who've made requests on your website. You can just do the same thing. Obviously, you won't have that like analysis of the data, but you can collect metrics about when they made the request, what page they were making a request on, what they were accessing, looking at time spent on the website, stuff like that. Pretty good. The thing I don't like about this tutorial, and it's purely my my problem. Like obviously it's my problem because I don't like it, right? But I don't particularly like tutorials that focus on features that are behind a paywall. And I know like if you're a company, you're probably going to advertise features that are behind the paywall anyway. Just and like making some features accessible so that users that aren't able to pay for it now are able to like learn it, and then like in a production environment you could use it with that company paying for it, right? Fair enough. That's completely fine, and that's completely valid for this, because the majority of this is just like, oh, you can use this behind the paywall, but you can use this. It is behind a paywall, but for local testing and like local learning and development, it's completely fine. There's probably just like a limit on the number of containers you can run, or pods or something, which is fair enough. I just don't particularly like tools that are behind paywalls, because it feels like, what's a good example? I can't think of a good example right now, but most of the time when, okay, I do have a good example, but I can't talk about it. One just popped into my head and I was like, I can't talk about you. But the main issue I have with stuff like that is when you're using that technology, you'll find that it's very nice to use, but certain things that you want to use are like, what's the right word? I don't want to use like a a mean word. I want to use a okay, a good word is nerfed. Some features are nerfed. Some tools are nerfed because they want to put things behind a paywall. That, oh, you have to pay for these additional features and stuff like that. I haven't used this, so I haven't run it on local, so I don't know if it's like that. But from my experience, it is most of the time like that. And if it is like that for this, then I do not like it. And that's most of the reason why I don't like tutorials that use like development tools that are behind the paywall. Just because if the tool is nerfed when it's not behind the paywall, like, fair enough, it's nerfed. But if you have critical things running off of it, that's like, oh, you need to have this running for you to be able to use it, what's the point? If it's critical, it shouldn't be behind a paywall. It should be accessible. Sure, some features not being accessible or like limiting features, completely valid, right? But if it's critical to it working, there's like one or two companies that I really want to call out for this, but I'm not gonna. But if it's critical for you to get it working, get it running, and actually using the thing in like a production environment, don't put it behind a paywall. Sure, sure, you can like, you need to make money. Just wrap it in with the bundle for saying that, oh, you want to use our tools, you need to pay money for it in the first place. Don't just be like, oh yeah, here's the free stuff, but then, oh, this critical infrastructure thing that you'll probably need in production, you gotta pay for, otherwise you're screwed. Like, weird. Anyway, yeah, I think this tour is pretty good. I would recommend it. One thing that I would say I would like to see more, and just because it was at the very end, if they went a little bit more into Gatling, that would have been cool. just because I don't personally know how Gatling works. I know some people who've used it and like really like Gatling, and I know it's not the main focus of this tutorial, but Gatling's really cool, and using it can help a lot with like testing servers that handle like HTTP requests. It's just really cool, and maybe seeing a bit more on how Gatling works would be nice. But that's purely, this is like unrelated to the tutorial because the tutorial's main focus isn't on Gatling. It's on Kafka, Kubernetes, Akka, and metrics and telemetry. So I understand why it's not focused, why it's not a key focus, but I would have just appreciated if there was like a little aside or something saying you can here's like some documentation on Gatling where you can like go and look into it yourself. If I go on the open setup, what does this take me to? Yeah, it does take me to the Gatling documentation, so that's like fair. And a GitHub repo for Gatling, that's fair. I just would have wanted to see a bit more in just a bit more on Gatling, but other than that I think it's pretty good. I say check it out. And yeah, I don't know if it runs on local, but as I didn't want to try running it on local, but it looks like it would. I don't see why it wouldn't, considering it's just running on Kubernetes containers. So anyway, next time we're going to build a form and play. Thanks for watching, like, subscribe, enjoy the rest of your day, and peace.